Ladies and gentlemen, please welcome NVIDIA founder and CEO, Jensen Huang.
Twenty years after we introduced to the world the first programmable shading GPU, we introduced RTX at SIGGRAPH 2018 and reinvented computer graphics. You didn't know it at the time, but we did, that it was a bet the company moment. The vision of RTX was to bring forward real-time ray tracing, something that was, of course, used in film rendering offline. It required that we reinvent the GPU, added ray tracing accelerators, reinvented the software of rendering, reinvented all the algorithms that we made for rasterization and programmable shading. And that wasn't even enough. We had to bring together computer graphics and artificial intelligence for the very first time to make it possible. In 2018, 5 years ago, this was the showcase demo. The first RTX GPU was called Turing. As you can imagine, we did it on purpose. It was appropriately named to unify computer graphics and artificial intelligence for the very first time. This demo was called Star Wars Reflection. It was created by the researchers at L&M, X Labs, Epic, and NVIDIA. It had 2.5 million polygons or so, 2 rays per pixel, a couple of bounces per ray. We did ambient occlusion, area lights, specular reflections. It was a hybrid rasterization and ray trace demo. We rendered it at 720p, 30 frames a second, and we used DLSS super resolution to scale it to 4K. The demonstration was, frankly, at the time, incredibly beautiful. That was 5 years ago. Now, 5 years later, Racer RTX, 250 million polygons, 100 times more geometry, 10 rays per pixel, about 10 bounces per ray. We're using a unified lighting system for every effect for the very first time. This entire scene is completely path traced, no rasterization. We're rendering it at 1080p, 30 hertz, and using DLSS, using artificial intelligence, infer something like 7 out of 8 pixels, computing only 1 out of 8, and as a result, we're able to render this at 4K, scale it up to 4K 30 hertz. Hit it. Not bad for real-time. I think it's safe to say that it was worth it to bet the company. We realized that rasterization was reaching its limits, and unless we took such a giant risk again and introduced a brand new way of doing computer graphics, combining CG and AI for the very first time, what you just saw would not be possible. Modern computer graphics has been reinvented. The bet has paid off. While we were reinventing computer graphics with artificial intelligence, we were reinventing the GPU altogether for artificial intelligence. The GPU, when I came to see you last time, 5 years ago, most people would say that this is what a GPU looks like. And in fact, this is the GPU that we announced. This is Turing. And you guys might remember this. This is the Turing GPU. But this is what a GPU is today. This GPU is, let's see, 8 hoppers, each one of them. All together, something like between the hoppers, the 8 hoppers connected with NVLink, the InfiniBand networking, the NV switches that are connecting them together, the NVLink switches, all together, 1 trillion transistors. This GPU has 35,000 parts. It's manufactured by a robot, like an electric car. It weighs 70 pounds, consumes 6,000 watts. And this GPU revolutionized computer science altogether. This is the 3rd generation. This is Hopper GPU. This is the GPU that everybody writes music about. There's a Billy Joel song written about this GPU. And so this GPU has gone on to reinvent artificial intelligence. And 12 years later, after 12 years working on artificial intelligence, something gigantic happened. The generative AI era is upon us. The iPhone moment of AI, if you will, where all of the technologies of artificial intelligence came together in such a way that it is now possible for us to enjoy AI in so many different applications. The revolutionary transformer model allows us to learn from a large amount of data that's across large spans of space and time to find patterns and relationships, to learn the representation of almost anything with structure. We learned the representation, how to represent language in mathematics and vectors, in vector space, audio, animation, 3D, video, DNA, proteins, chemicals. And with a generative model and the learned language model, you can guide the autoregressive diffusion models to generate almost anything you like. And so we could learn the representation of almost anything with structure. We can generate almost anything that we can learn from structure. And we can guide it with our human natural language. The journey of NVIDIA accelerated computing met the journey of the deep learning researchers. And the big bang of modern AI happened. This is now 12 years later, the 12-year journey of our work in artificial intelligence, and it is incredible what is happening around the world. The generative AI era has clearly started. The combination of large language models and generative models, these autoregressive generative models, has kicked off the generative AI era. Thousands of papers in just the last several years have been written about this area of large language models and generative AI. Billions of dollars are being invested into companies, and just about every single domain and every single industry is pursuing ideas on generative AI. And the reason for that is very simple. The single most valuable thing that we do as humanity is to generate intelligent information. And now, for the very first time, computers can help us augment our ability to generate information. And the number of startups are just doing amazing things. Of course, they're doing content creation, but they're also using generative AI to steer the steering wheel of a self-driving car, or animate, articulate the robotic arm, generate proteins, chemicals, discover new drugs, even learning the structure of physics so that we can generate physics of mesoscale multiphysics, maybe accelerate the understanding of climate change. Well, here's some examples of some amazing things. This is the Adobe Firefly. Adobe Firefly does outpainting. Imagine the space around the image that we never captured. Move AI does mocap from just video. This is on the upper right. You decide which one's real. I'm going with the left. Viscom does sketch to image guided by language prompt. This one's really cool. There are a lot of people who know how to sketch, and from the sketch and some guidance from your language, you could generate something photorealistic and rendered. The future of computer graphics is clearly going to be revolutionized. And this is really cool. Wonder Dynamics, not only is the name of the company cool, but they do pose and lighting detection and replace the actor with a CG character. It just goes on and on and on. The number of generative AI startups around the world, I think we're coming up on something like 2,000. And they're in just about every single industry. The generative AI era has arrived. Well, what's really profound, though, is that when you take a step back and ask yourself, what is the meaning of generative AI? Why is this such a big deal? Why is it changing everything? Well, the reason for that is, first, human is the new programming language. We've democratized computer science. Everybody can be a programmer now because human language, natural language, is the best programming language. And it's the reason why ChatGPT has been so popular. Everybody can program that computer. Large language model is a new computing platform because now the programming language is human, and what you program that computer understands large language models. And generative AI is the new killer app. These three insights has gotten everybody just insanely excited. And because for the very first time, after 15 years or so, a new computing platform has emerged. Like the PC, like the internet, like mobile cloud computing, a new computing platform has emerged. And this new computing platform is going to enable all kinds of new applications, but very differently than the past. This new computing platform benefits every single computing platform before it. Notice, one of my favorite, the thing I'm looking forward to most is generative AI for Office. There are so many different things that I do in Office today. It would be great to plug in generative AI to help me be more productive in that. Generative AI is going to be plugged into just about every digital content creation tool, every single CAE tool, every single CAD tool. For the very first time, this new computing platform not only enables new applications in this new era, but helps every application in the old era. This is the reason why the industry is moving so fast. Well, one of the important things that's going to happen is this application space, this new way of doing computing, is so profoundly different that the computer will be reinvented. The computer itself will, of course, process information in a very different way. And we need a new processor. The computers in the world, computing is done in so many different places. And sometimes they're used for training, sometimes they're used for inference, sometimes they're in the cloud, sometimes it's for scale up, sometimes it's for scale out. Sometimes it's for enterprise, sometimes it's underneath your desk in your workstation. There are so many different ways that computing needs to be refactored. And NVIDIA's accelerated computing will support every single one of those. But one particular area is extremely important, which is the basic scale out of the cloud. The basic scale out of the cloud historically was based on off-the-shelf CPUs, x86 CPUs. While general purpose computing is a horrible way of doing generative AI, and you could see that in just a second. And so we created a brand new processor for the era of generative AI. And this is it. This is the Grace Hopper. We announced Grace Hopper, in fact, just only recently, several months ago. And today we're announcing that we're going to give it a boost. We're going to give this processor a boost with the world's fastest memory called HBM3E. The world's fastest memory now connected to Grace Hopper. We're calling it GH200. The chips are in production. We'll sample it at the end of the year or so and be in production by the end of second quarter. This processor is designed for scale out of the world's data centers. It has 72 cores. Grace CPU core is connected through this incredibly high-speed link cache coherent, memory coherent link between the CPU and the GPU. This is the CPU, and that's the GPU. The Hopper GPU is now connected to HBM3E. It has 4 petaflops of transformer engine processing capability, and now it has 5 terabytes per second of HBM3E performance. So this is the new GH200, based on the architecture, Grace Hopper, and a processor for this new computing era. There's a whole lot of ways that we can connect Grace Hopper into a computer. This is one of my favorites. By connecting 2 of them into one computing node, connecting it together with NVLink, and this NVLink between these 2 processor modules is 6 terabytes per second. And it basically turns these two processors, these 2 super chips, into a supersized super chip. One giant GPU, one giant CPU. The CPU now has 144 cores. The GPU has 10 terabytes per second of frame buffer bandwidth. 10 terabytes per second of frame buffer bandwidth, and 282 gigabytes of HBM3E. Well, pretty much you could take just about any large language model you like and put it into this, and it will inference like crazy. The inference cost of large language models will drop significantly because look how small this computer is. And you could scale this out in the world's data centers because the servers are really, really easy to scale out. You can connect this with Ethernet, you can connect it with InfiniBand, and of course, there's all kinds of different ways that you can scale it out. Let's take a look at what it means if you were to scale it, take this, and now scale it up into a giant system. This is 2 GPUs, but what if we would like to scale this up into a much, much larger GPU? Run it, please. All right. This is actual size, by the way. This is actual size, and it probably even runs Crysis. The world's largest single GPU. 1 exaflops, 4 petaflops per Grace Hopper, 256 connected by NVLink into one giant system. And so this is a modern GPU. So next time when you order a GPU on Amazon, don't be surprised if this shows up. Okay, so that's how you take Grace Hopper and scale it up into, of course, a giant system. Future frontier models will be built this way. The frontier models of the past, like GPT-3 and GPT-4 and Llama, are the mainstream models of today. Only after a couple of years, these frontier models, which were just gigantic to train on systems like this in the future, becomes mainstream. And once they become mainstream, they could be scaled out into all kinds of different applications. And how would we scale these out? And so let me show you this. This is how you would do it. And so now you would have a single Grace Hopper in each one of these nodes. This is the way computing was done in the past. For the last 60 years, ever since the IBM System 360, the central processing units or general purpose computing was relatively mainstream. And for the last 60 years, that's the way we've been doing computing. Well, now, general purpose computing is going to give way to accelerated computing and AI computing. And let me illustrate to you why. The canonical use case of the future is a large language model in the front end of just about everything. Every single application, every single database, whenever you interact with a computer, it will likely be first, you'll likely be first engaging a large language model. That large language model will figure out what is your intention, what is your desire, what are you trying to do given the context, and present the information to you in the best possible way. It would do the smart query, maybe a smart search, augment that query and search with your question, with your prompt, and generate whatever information necessary. And so the canonical example that I'm using here is a Llama 2 large language model that is being inferenced. It then does a query into a semantic database, a vector database of some kind, and the output of that is augmented and becomes a guide for a generative model. And here, the generative model I'm using is Stable Diffusion XL. And so these three models, Llama 2, vector database, and Stable Diffusion SDXL, are relatively well understood as state-of-the-art and the type of models that you could imagine running just about everywhere. Well, if you were to have an ISO budget way of processing that workload, it would take, let me just choose a number, $100 million, and $100 million would be a reasonably small data center these days. $100 million would buy you about 8,800 x86 GPUs. It would take about 5 megawatts to operate that, and I normalize the performance into 1x. Using the exact same budget with accelerated computing Grace Hopper, it would consume only 3 megawatts, but your throughput goes up by an order of magnitude. Basically, the energy efficiency, the cost efficiency of accelerated computing for generative AI applications is about 20x. 20x in Moore's law and just the current way of scaling CPUs, that would be a very, very long time. And so this is a giant step up in efficiency and throughput. So this is ISO budget. Let's take a look at this now again, and let's go through ISO workload. Suppose your intention was to provide a service, and that service has so many number of users, and so your workload is fairly well understood, plus or minus. And so with ISO workload, this 1x, $100 million using general purpose computing and using accelerated computing, Grace Hopper, it would only cost $8 million. $8 million and only 260, not megawatts, yeah, 0.26, 260 kilowatts, so 20 times less power and 12 times less cost. This is the reason why accelerated computing is going to be the path forward. And this is the reason why the world's data centers are very quickly transitioning to accelerated computing. And some people say, and you guys might have heard, I don't know who said it, but the more you buy, the more you save. And that's wisdom. If I could just ask you to remember one thing from my talk today, that would really be it. That the future is accelerated computing, and the more you buy, the more you save. Well, today I want to talk about something really, really important. And so the backdrop, accelerated computing. The backdrop, generative AI. The backdrop, the things that, real-time ray tracing. The future of computer graphics unified with AI. Let's talk about a couple of new things. And so today I want to talk about Omniverse and generative AI and how they come together. The first thing that we already established is that graphics and artificial intelligence are inseparable. That graphics needs AI, and AI needs graphics. Graphics needs AI, and AI needs graphics. And so the first thing that you could imagine doing for the future of artificial intelligence is to teach it common sense. All of us understand the consequences of the physical actions we take. All of us understand that gravity has effect. And all of us understand that even though you don't see something, that object might still be there, probably is still there, physical object presence. And so that common sense is known to humans ever since you're babies. And yet, for most artificial intelligence agents that learned on large language models, it's unlikely it has that common sense. That object permanence, the effects of gravity, the consequence of your actions, you have to learn it in a physically grounded way. And so the thing that we could do is we could create a virtual world that is physically simulated, physics simulated, that allows an artificial intelligence to learn how to perceive the environment, using a vision transformer maybe, and to use reinforcement learning to understand the impacts, the consequences of its physical actions, and learn how to animate and learn how to articulate to achieve a particular goal. And so one mission of a connected artificial intelligence system and a virtual world system that we call Omniverse is so that the future of AI could be physically grounded. The number of applications is really quite exciting because, as we know, the largest industries in the world are heavy industry, and those heavy industries are physics-based, physically based. And so, first application is so that AI can learn in a virtual world. The second application, the second reason why AI and computer graphics are inseparable is that AI will help also to create these virtual worlds. Let me give you a couple of examples. This is an AI that is a large language model, as I mentioned, that will be connected to almost every single application. However, the future user interface of almost every application is a large language model. And so it's sensible to imagine that this large language model could also be a query front end to a 3D database. And so here, I find a Denza N7 SUV. Now, once you find this SUV, you might ask an AI agent to help you to turn this car, to embed this car, to integrate this car into a virtual environment. And instead of designing that virtual environment, you ask the AI to help you. Give me a road in the desert at sunset. Now, inside Omniverse, we can then unify, aggregate, composite this information together, and now the car is integrated, rendered into, positioned into a virtual world. And so here's an AI that helps you maybe create and find some manage your data assets. You also have an AI that helps you generate a virtual world around it, and Omniverse allows you to integrate all this information. Well, let's take a look at what WPP, the world's largest ad agency, and BYD, the world's largest electric vehicle maker, how they're using Omniverse and generative AI in their work. Play it, please.
WPP is building the next generation of car configurators for automotive giant BYD's Denza luxury brand, powered by Omniverse Cloud and generative AI. OpenUSD and Omniverse Cloud allows Denza to connect high-fidelity data from industry-leading CAD tools to create a physically accurate, real-time digital twin of its N7. WPP artists can work seamlessly on this model in the same Omniverse Cloud environment with their preferred tools from Autodesk, Adobe, and SideFX to deliver the next era of automotive digitalization and immersive experiences. Today's configurators require hundreds of thousands of images to be pre-rendered to represent all possible options and variants. OpenUSD makes it possible for WPP to create a super digital twin of the car that includes all possible variants in one single asset, deployed as a fully interactive 3D configurator on Omniverse Cloud GDN, a network that can stream high-fidelity, real-time 3D experiences to devices in over 100 regions, or used to generate thousands of individual pieces of content that comprise a global marketing campaign. The USD model is placed in a 3D environment that can either be scanned from the real world using LiDAR and virtual production, or created in seconds with generative AI tools from organizations such as Adobe and Shutterstock. This innovative WPP solution for BYD brings generative AI and cloud-rendered real-time 3D together for the first time, powering the next generation of e-commerce.
God, I love that. Everything was rendered in real time. Nothing was pre-rendered. Every single scene that you saw was rendered in real time. Every car, all of the beautiful integration with the background, all the rendering, everything is 100% real time. The car is the original CAD data set of BYD. Nothing was changed. You literally take the CAD, drag it into Omniverse, you tell an AI, synthesize and generate an environment, and all of a sudden, the car appears wherever you like it to be. So this is one example of how generative AI and human designs come together to create these incredible applications. And so how do we do this? Applications, generative AI models are making tremendous breakthroughs. And what you want to do, we all want to do this. There are millions of developers and artists and designers around the world, and companies, every single company would like to take advantage of, and certainly everybody at NVIDIA working hard to utilize large language models and generative AI in our work. In fact, the Hopper GPU was impossible to design by humans. We needed AIs and generative models to help us find the way to design this thing in such a high-performance way. And so it augments our design engineers. It makes it possible for us to create some of these amazing things at all. And of course, the productivity of the teams go up tremendously. Well, we would like to do this in just about every single industry. So the first thing that we have to do is we have to go find a model that works for us so that we can fine-tune it. You can't just use the model as is. You want to fine-tune it for your curated data. The second thing you want to do is to augment your engineers, your artists, your designers, your developers with the capability of these generative models. So augmenting it, composing the information together. In this particular case, I'm using media and entertainment or virtual world as an example, and this is the reason why Omniverse is central to that. We want to be able to run this in the cloud, of course, and we'll continue to run this in the cloud, but as you know, computing is done literally everywhere. AI is not some widget that has a particular capability. AI is the way software is going to be done in the future. AI is the way computing will be done in the future. It will be literally in every application. It will be run in every single data center. It will run in every single computer, at the edge in the cloud. And so we want to have the ability to not just do AI, generative AI in the cloud, but to be able to do it literally everywhere. In the cloud, in data center workstations, your PCs. And we want to do this by making it possible for these really complicated stacks to run. There's a reason why the world's AI is done largely in the cloud today. We partner very closely with the CSPs. The amount of acceleration libraries and all the run times, and from data processing to training to inference to deployment, the software stack is really complicated. The libraries, the runtimes, just getting it to run on a particular device and system is incredibly hard. And that's the reason why it's stood up as a managed service that everybody can use. Well, we believe that in order for us to democratize this capability, we have to make it run literally everywhere. And so we have to have these unified optimized stacks be able to run on almost any device and make it possible for you to engage AI. Well, the first question is, where are the world's models? Well, the world's models are largely on Hugging Face today. It is the largest community of AI, the largest AI community in the world. Lots and lots of people use it.